Okay, so for problem number 39, it says when a pilot drops a bomb from an airplane horizontally at a constant speed, when the bomb hits the ground, where will the plane be? Alright, this is kind of an easy one. Let's check it out. So I have a plane. And they drop a bomb. Okay. Now both of them have the same velocity in the x direction. Now as they progress, what happens is that the plane, for the most part, stays on that same path with the same velocity. Right? Now the only thing that changes with the bomb is because of gravity. It actually will hit the ground because gravity forces it to come down. But the velocity in the x direction does not change. The only thing that's changing is that it now has a velocity in the y direction. And the total velocity of this is the resultant vector of these two vectors. But as they move across, in other words, I'll let this green marker represent my airplane, and I will let this thumbtack, as soon as I open up my thumbtacks, represent the bomb. So as I drop the bomb, as the plane flies by and I drop this bomb, what happens is they don't change their velocity in the horizontal direction. So when it finally does hit the ground, and it will hit the ground eventually, the plane will be right above the bomb. Okay? Does that make sense? So the answer should be directly on top of one another, right? The plane will be over the bomb. Yep. And the reason for that is that the acceleration in the x direction for everything is 0. So if there's no acceleration, there's no change in either x direction. Now the plane has lift and stuff that keeps it going in the the overall resultant vector. In other words, the plane has lift which goes this way and then gravity pulls down. These two cancel each other out and it just has a horizontal velocity. But there's nothing keeping the bomb floating. The bomb doesn't have any wings, so gravity acts upon it. So the acceleration in the y direction is equal to negative 9.8 meters per second. So the only thing that changes is that the bomb drops to the ground. But they're going the same velocity, right? So their distance, their displacement, delta x in the x direction for the plane, or we'll just say plane, will be equal to the velocity of the plane times time. While the displacement of the bomb will be equal to the velocity, and this is in the x direction I should say, of the bomb times t. Well, the velocity of the plane in the x direction and the velocity of the bomb in the x direction are exactly the same. And the time is the same, therefore the displacement would be the same, right? So if we go from here and consider this x sub 1 and consider that x sub 2, they both will have traveled the same distance.